Hello, thank you all for all your questions for me as asked the professor. I saw a lot of questions and it makes me really grateful that you did send this to me. And now I can give you some answers, not all of them, but I have selected 3 of them and I will give feedback on these questions to you. Question number 1, I will read that. We have steel rail tires running against steel rails and it produces a lot of noise and which adversely affects a lot of people. So the question is, how can we solve this or can we get rid of this noise? We have a wheel-rail contact and wheel-rail contact is against steel. Is this wise? No, it's not wise because when you look at the physics says this is the most stupid combination you have. Why do we do this? Because we have 2 things. It must be cost effective, so it must be a low cost, and we have a low rolling resistance. Therefore we need this steel-steel combination. And how to get rid of the noise? That could be in 2 reasons. Or you put a wall to get rid of the noise against the rail, so on the side. Or you look inside the wheel-rail contact and can we put something in between so we don't get this noise, because we have not only the friction but also the spin and the creepage in the contact when you go through a curve or in the switch. You hear that high frequency noise as squeal, and this screaming of the rail you don't like, so we have to get rid of this. So you can also put a friction modifier in between, so you more or less lubricate the wheel-rail contact, so this spin and creepage will not get any noise effective and also affects the people. These are the 2 combinations to get rid of it. Another one is, can we choose another material of the wheel or rail? So you can choose other wheels, for example. Also the question was, can we use graphene on this? And then the question should be, okay, is this cost effective or not? And I think graphene is a wonderful material, but most expensive, and we don't have a problem about the stronger material do we need? No, we don't need. So why not using the old material we have, because that is more cheaper than graphene. So what you can see here is now the test rig running on the speed of 20 kilometers an hour. We have a scale 1 to 5. That means that we have, in principle, a speed of 100 kilometers per hour outside the wheel. You see 4 arms on the test rig, so we have 4 wheels running around. And you hear also the sound of bumping against something. That we make some small slides off of the rail, of the top of the rail, and therefore you hear that bumping of this of the rail contact, what you also see outside when we have an insulated joint, for example. So this test rig, we can test all kinds of situations outside, inclusive the ballast or ballastless track and special grades of steel for the wheel and the rail itself. Thank you for question number 2. I will explain. And the question is, sanding is typical use in heavy rails. For light rail and metro sanders are not included. The question is that true? I think it's not. When we look in Holland, we use a lot of sanding, especially for tram in the cities, because of all the moisture we have on the rail. So when you like to get rid of this, it is useful to get rid of it. No, I think sand is also helping for the friction and also for tram or metro. So light systems also use sanding systems. The question was, do we get a lot of rains in Singapore and therefore we get a reduction of the adhesion? Yes, it is true. When it is raining, you get a lower adhesion because the friction coefficient is getting lower and therefore you get slippery tracks. How to get rid of slippery tracks? You could say, okay, we build a tunnel. That's a lot of cost to do, but you can also think about, can we use materials to get rid of this slippery track? And in the old days, sand is really helpful. Still we use, and also at tram and metro systems, and you can also do it in a modern way like sandite. Sandite is more like a gel with sand and other materials to get a more friction on the top of rail. And what you also can do is using friction modifiers to put it on board, spray on the top of the rail, so you get special material in between the wheel and the rail to get rid of this slippery track. I also can show this on the test rig. I'm standing here. and we can show how this works and what we mean by slippery track and how sanding is working in this wheel-rail contact. When we look at this machine, we have a test rig to test wheel-rail conditions in the wheel phase outside, but we have here scaled and downsized the system as it is outside. What we can do and produce here is slippery track, because we can use leads and we put it on the rail and we can smash them by this test rig. So I will put some leads on and we can make slippery track. So now we will run the machine and get over it, and let's see what happens. What you can see now is that because of the wheel and the pressure you get on the rail, that you see a lot of dark spots and also squeezed bio material on the top of rail. When you put here also water on it, it is really slippery, and that's why we have these slippery tracks and also flat spots on the wheels in rail track. So how to get rid of this slippery track? That could be by using sand. So I will use sand on it, and then you can see what happens when we go over by wheel. So also you can hear the sound of crushing these sand particles, and that's exactly what happens. So the sand is really hard and brittle, and you put them by the high pressure of the wheel, you put it inside the steel, and you get rid of these black spots, and therefore you have no slippery track anymore. You can see this by hand. It is really putting inside the steel, and you get also a rough structure on top of rail, and therefore you crush away this black bio material away. So it works. So sanding is a real good recipe from the old days, but still active on the modern railway. For today we have the last question, and that's the question about wooden sleepers versus concrete sleepers. What are the benefits of this? And the last one is, what about plastic sleepers? Is that also a possibility in railways or not? And by the way, I have here two sleepers on our laboratory. We have here a wooden sleeper and a concrete sleeper. What is the difference? You can also see the size of them. So when you have concrete, it's much bigger and also a higher weight. So they have benefits because a higher weight organizes more stability of the rail track when the train is passing by. But dynamically, high weight means that the dynamic flow is really slow, and that gives a hard point, and we don't like hard points in the track. So wooden sleepers has benefits against this one, because this one is heavier and this one is low weight. But this low weight has also another benefit, because wood is also flexible. And flexible means that we have impact of forces because of a flat wheel spot, for example. It is easier and also easier of bending. And the connection between the interface between the ballast and underneath of the sleeper has a better contact and will longer life for the ballast than with concrete against ballast. So there are some benefits and disadvantages when you look to each other. Why do we use, for example, much more this type of sleepers than the wooden sleepers? In the old days, wooden sleepers could use chemicals, so the longer lifetime of the sleeper. That's not allowed anymore, so we can only use normal wood, and that will have a lifetime of, say, 10 years, not more. This one has a lifespan of 40 years, and therefore this one is more favored than the old-fashioned way by wood. What about plastics? Yes, we have regulations in Holland that we can also use plastic sleepers. It's allowed, and we use them especially when we have little problems with tunneling or other things just crossing the railroad. So we have a less ballast thickness, and how to solve this problem by elasticity. And therefore you can use plastics, and plastics can you introduce different elasticity inside the plastic. And also you use and recycle the plastic we normally have in our garbage. So that's also a beneficial thing. Is it useful to use it? Yes, it is, but it's also costly. And when you look at the efficiency of costs, wooden sleepers is more or less in between plastic sleepers, then you have wooden sleepers, and the cheapest one is concrete sleepers. Thank you very much for all the questions you sent to me. I also enjoyed it. I learned from that. When you look at the amount of countries who are participants in this MOOC, you can also see that on the world map we have included on online series. You see a lot of interesting differences on railways all over the world, and also enjoy that very much. So please keep up the right spirit for this and continue for the next weeks. I will be back for you to answer some questions you have already, so please collect them, send them online, and we'll be back within 2 weeks for you to give an answers you have for me on this railway MOOC. Thank you.